Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on February 12, 2026, just about 4 days ago. It introduces a technique called region-to-image distillation that allows multimodal models to capture fine-grained details in a single pass, achieving the accuracy of zooming in without the heavy computational cost, making the process roughly 10 times faster. The paper is titled, Zooming Without Zooming, Region-to-Image Distillation for Fine-Grained Multimodal Perception. And as we'll see later, the results show this method can significantly boost performance on tasks requiring precise visual attention. And for those interested in the implementation, the authors have shared their code on GitHub. The 4 billion, 7 billion, and 8 billion parameter models are on Hugging Face, including usage examples, to help you get started with single-pass fine-grained perception. Alright, Figure 1 puts these numbers in perspective by comparing average scores across several perception benchmarks. The blue bars show the proposed ZWZ models, while pink and gray represent closed and open source competitors, respectively. Notice that the ZWZ-8B model achieves a score of 77.6, landing right next to the state-of-the-art Gemini 3 Flash. Even more impressively, the compact ZWZ-4B model actually surpasses the massive QN3VL235B, demonstrating that this distillation technique allows smaller models to rival giants. Well, Figure 2 explains how they achieve this efficiency by contrasting the workflows. The top section illustrates previous thinking with images methods, which depend on a repetitive loop of reasoning, tool calling, and re-encoding crops, a cycle that burns significant time and compute. In contrast, the bottom section maps out the new approach. It shifts that zooming process entirely to the training phase on the left, distilling detailed regional knowledge into the main model. Because of this, the final deployment pipeline on the right becomes a direct, single-pass inference, simply moving from query to answer without any iterative delays. So, Figure 3 breaks down the training pipeline, called region-to-image distillation. On the left, the system performs zoom-in synthesis by identifying tiny regions, like the license plate on the taxi, and cropping them for a teacher model to generate precise Q&A pairs. Then, moving to the right, the pipeline shifts to distillation. It applies that same question to the full image, but helps the student model by overlaying a visual bounding box and adding a text prompt that points to it. This creates training data that forces the network to resolve fine-grained details within a busy global context. Okay, having established the training process, Table 1 introduces the evaluation ground, a new benchmark called ZoomBench. It compares this new suite against existing datasets like CVBench and HRBench. Notice that most prior benchmarks, listed in the upper rows, rely mostly on multiple choice formats and lack specific evidence annotations. In contrast, the bottom row shows that ZoomBench supports both multiple choice and open questions. Crucially, it stands out by offering a unique dual view protocol, which allows researchers to explicitly quantify the gap between looking at a crop versus the full global image. Alright, with the benchmarks defined, Table 2 reports the main performance numbers. The bottom rows list the ZWZ models. If you look at the first data column, for ZoomBench, the ZWZ-8B model scores over 58%, which is a huge leap from the baseline QN3VL-8B at roughly 38%. Moving to the general perception average column, highlighted in green, ZWZ-8B achieves about 78%. This is remarkable because it outperforms the massive 1 trillion parameter K 2.5 and rivals the closed-source Gemini 3 Flash, proving that compact models can punch well above their weight. So, while the previous table showed raw accuracy, Figure 5 reveals the critical speed advantage. Here, the vertical axis tracks benchmark accuracy, and the horizontal axis measures inference speed in samples per second. Look at the blue circles on the far left. These represent thinking with images methods like DeepEyes and tool-augmented models. They achieve high accuracy, but they are incredibly slow, often processing fewer than 0.5 samples per second due to repeated tool calls. In contrast, the orange squares on the right represent the proposed ZWZ models. The ZWZ-8B model sits at the top right corner. It not only reaches the highest accuracy, over 82%, but also runs about 10 times faster than the tool-based baselines, effectively combining the best of both worlds. Wrapping up, The big takeaway is that the benefits of thinking with images can be internalized into a single forward pass. By distilling regional knowledge, smaller models can now match the fine-grained accuracy of massive systems while running 10 times faster. This offers a promising path for efficient, high-resolution perception without slow tool loops. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.